6.3. It is still about volumes, but this time we have a new method, a new technique to find the volumes of solids of revolution. Why we need this method and how to use it, this is what we are going to learn today, inshallah. To see why we need this method, and mostly in most of the regions is better than the other methods, let's consider the problem of finding the volume of the following solid. What is this solid? If you look at it, it is the solid obtained by rotating the following region, the region bounded between 2x squared minus x cubed and y equals 0. Let's assume that we are able to, of course, sketch this one. This is just a polynomial. You know how to sketch polynomials. You will take x squared as a common factor, then you will have 2 minus x. You know how to sketch the graph of this. You have two zeros, you have 0 and 2. These are the x-intercepts, the zeros of the polynomial. And of course, the end behavior, this one will be up to the left, down to the right. And it has, of course, here at x equals 0, it has a tangent. So it will do something like this. It will continue doing like this. Now, of course, what you need to focus on is this region in the first quadrant. Now, how to find this, ya shabab, in terms of the methods of section 6.2? If you remember, we learned the technique there that we can use the disk method or the washer method. They are, of course, related methods. The disk method is just a special case from the washer method. By the way, here the axis of rotation, what is it? It is the y-axis. This is the axis of rotation. What we will have, ya shabab, if we applied 6.2 here, volumes or disks by disk or washers, what we are going to have, a disk or a washer?
Washer.
You know, ya shabab, you remember that what we usually do, we draw a line. In fact, it is, as I told you, it is a typical rectangle. But for short, you know, we just, consider it as a line like this. Usually what we do in the disk method or the washer method, we will draw a line from perpendicular to the axis of rotation through the region from the right to the left, from above to below. It depends. So it is a horizontal line, so it must from the right part to the left part. You should ask yourself, how many curves I have to the right? Only one curve. And how many curves to the left? Only one curve. So it is good, because if it is otherwise, you need 2 integrals or 3 integrals. It depends. So now you remember next what we do, we find the length. Since this one is a horizontal, so the thickness variable is delta y. Here you have y, so it could be at any place. So because of this, here you will integrate with respect to y if you want to apply the washer. Why it is a washer, not a disk? Because the axis of rotation is not a boundary of the region. So because of this gap here, we have a gap here, we have a space between the region and the axis of rotation. So our cross section will be a washer. Now, you know, to find the length of this line, shabab, you need to ask yourself, what is x here? And what is x here? What is x right? What is x left? But this is not easy. To do that, you need to solve this equation for what?
For x.
For x, and this is not easy. It is not easy to solve this for x, ya shabab. Try to do that. It is not. So to know what is the curve on the right, what is the curve on the left, it is not easy. So when you have a curve like this, it is not practical at all to use the washer methods. So in this case, we are lucky. We are so lucky to have another method that is called the cylindrical shells method. It is a totally different technique. So it does not depend on cross sections. You know, if you want to give 6.2 a name, it is volumes by using cross sections. Here you have mainly two methods: cross sections method and cylindrical shells method. So this is a different technique. To understand what we mean by shells, by the way, cylindrical shells, what are cylindrical shells? What you are looking here is different types of cylindrical shells. When you have a solid, you can divide it or slice it or whatever into cylindrical shells. Think about this is a cup, ya shabab. When you have a cup inside another cup, inside another cup, until in this, and then if you can find the volume of this one, then the volume of this one, then the volume of this one, then the sum of the volumes of these shells will be the whole volume of the whole solid. What is to understand what we mean by cylindrical shells and how it looks like and how to find the volume of one cylindrical shell, you need to remember the cylinder, shabab. This is a cylinder, and you know if you want to find the surface area of this cylinder, you can cut it here and then expand it. So this is the radius of the base, r, h is the height. So in this case, the surface area will be 2 by r times h. The area of this cylinder, it is just the area of this rectangle. So it will be 2 by RH. Now, when you have a thickness, of course, you have some thickness here for this. This is 2D object. If it is 3D like this, and you have the third dimension here, let's call it dr. Okay, so for example, it is coming from r. This is r. Here we will call this small part here dr, because we were having here r. In this case, the same way, if you cut it at this place and then expand it, you will have this rectangular box. This rectangular box, it has a volume. Its volume will be just the 3 dimensions multiplied each by each other. So it will be this 2 by r multiplied by the thickness variable multiplied by h. So it is 2 by, it is just like this, but it is multiplied by a new variable delta r. So this will give you the volume of the cylindrical shell. Remember this, shabab. We will use this 2 by r h dr. In our case, dr will be just delta x or delta y. It depends on the function that you have and the region that we have. Is it clear, shabab, how to find the volume of a cylindrical shell? Good. So let's go now to apply and to see why and how to apply this method and what is it indeed. Let's consider, yes.
We just use the last law you write it in the, V equal to by r.
No,
RH.
as an integral, we will see together, but I want you to recall this. Of course, we will have the formula later. We will now formulate the formula. We will see together from where it is coming. I don't want you just to memorize it. Also, it is good to have an idea from where it is coming. So let's imagine that you have this region. Of course, you can find it. Of course, here the axis of rotation is the y-axis. And this is the region. We assume that y here is greater than 0. And from A to B. طبعا you can, shabab, solve this one by the disk method or the washer method. If you want to find the volume by the cross sections method, what you will use? Which is it, disk method or washer? The cross section. What you will do just to distinguish between the cross sections method and the cylindrical cells method. Remember, if you want to use the cross sections method, what you will do? You will draw a line parallel, or sorry, perpendicular. It will be perpendicular on the axis of rotation. Then you will ask yourself, what is x here and what is x here? The problem here, shabab, that the curve on the right is not one curve. You have 2 curves. So you have to do it here as 2 integrals. You need to find the volume up to here, then the volume of another region. So you need to divide it into 2 integrals here. So it is not practical to use the cross sections method. Okay? But of course you can, but you will spend more time and more calculations. Now, what we will do to use another method or to think about it in a different way. Look, when you rotate this, when you rotate it about the y-axis like this, the whole region about the x-axis, this is what you have. This is the solid that you will get. Okay. Previously in the cross sections method, what we usually do, ya shabab, we cut this horizontally or vertically. It depends. Do you want to integrate with respect to x or with respect to y? Usually we cut it, we slice it into cross sections, and then we find the volume of each cross section, and then of course we let that number of these cross sections go to infinity, and we apply the definite integral definition. Now, what we will do as a new technique, we will not slice it into cross sections. What we will do, we will try to think about this like, do you remember the cup that I told you about before? So we will try to think about this as a sum of shells. So let me make it easier by looking here. Look here. So what we will do, the y-axis is the axis of rotation. So we will not draw a line parallel, perpendicular to it. We will draw a line, which is here, in fact, stands for the typical rectangle. So it is the same way that we did for areas. You remember, we will divide it into sub-rectangles. So let's take one of them as an arbitrary one, as a typical rectangle. So here we will draw a line parallel to the y-axis. Because it is a vertical line, its equation will be x equals to x, something variable between a and b. Now, this is as I want you to think about it like here. Look, this is a rectangle here, a rectangle. These are some of rectangles. Now, think about rotating this. Let's rotate this one, this rectangle. Okay, here it is. You will have this one. Look at it. This one, ya shabab. It is just this one, the one that we have here. It is, in fact, if you look at it, you will have a cylindrical shell. It is a cylindrical shell. Another one, if you rotate this rectangle and this rectangle by the same way, you will have this one, then this one, this one, this one, then this one. Okay, so you will have kind of. Let me. I think onion. It is good example. Yes. You will have something like this. So now we have, in fact, we will think about like we will fill in this solid by some of cylindrical shells. So if I can find the volume of this shell, for example, as a typical shell, then I will have n. Let's say that we have n shells. So the sum of the volumes of these shells will give me the volume of the whole. Of course, solid, of course, approximately. So now the question is, what is the volume of the typical shell here? So let's think about one of them only. I think we have it here. Let's think, ya shabab, about one only. So what we will do, we will draw a line here, and then we'll imagine that we rotate it. So we rotate this rectangle, and we have this shell. So this is the typical shell. What is the volume of the typical shell? To find what is it, let's say that we have here the thickness variable is delta x, so it is xi minus 1. Let's take the midpoint, for example. The midpoint, you can take any point, no problem. Take the midpoint as a simple point. Then the height, of course, of this rectangle will be the value of the function at xi bar. So this will be the height. Now what will be this is the shell. The radius of the shell will be this one. Of course, the center will be the axis of rotation. So this is the distance from here to here is the radius of the shell. And from here to here, it is the height of the shell. So this is h, this is r. It is clear, Shabab, what is h? H here, it is the height. And what is r? It is the value of the function at xi bar. What is, ya shabab, the radius here? Who can tell me? The distance from here up to here. What is it?
X.
X bar, yes, it is x. So the radius is xi bar, طبعا. And the height is f of xi. So this is the height. And of course the thickness variable is delta x, because we have the rectangle like this, perpendicular on x-axis. So the thickness variable is delta x. Okay. So now this is for one shell. Of course, if you have n shells like 4, here we have 5 shells. If you have so many shells, you will have exactly, if you increase n, if you let n goes to infinity, you will have exactly the volume of your solid. Now, do you remember what I told you? What I told you to recall here? What is the volume of the cylindrical shell, ya shabab? It is 2 by RH dr. This is for one cylindrical shell. Now, according to this is H, this is R. So what will be the volume? The volume will be 2 by the volume of one cylindrical shell of this one. The volume will be 2 by R H delta R. Okay. In our case, this is R, this is H, and this one is delta R. Is that clear? How we did find the volume of one Tribeca shell. Now what we will do, we will sum them up. This is for one shell. So if you have n shells, this is the volume of n shells. Now, of course, if you let n goes to infinity, what you will have? If you let n goes to infinity, then take that, this will be the definition of the integral, and you will have 2 by x dx. So to summarize, if you want to find the volume of this region under the curve of the function y equals f of x from a to b, by using the Shells method, this volume, the exact volume of this solid will be just the integral from a to b for 2 by x. This x, in fact, it is the shell radius, the radius of the shell, and this f of x, it is indeed the height of the shell, and dx is the thickness variable. This is when we have the axis of rotation is the y-axis. Any question, Shabab? I heard someone asking. What was your question? Okay, let me repeat this, ya Shabab. It is important. Turkey, what do you want, ya Turkey? Okay, now, ya Shabab, let's repeat that. If you have a region bounded above by y equals f of x and below by the y-axis, so y here is 0, y here is f of x. If the axis of rotation is the y-axis, what you will do to apply the Shells method? You will draw a Tribeca rectangle. By a Tribeca rectangle here, I will represent it as a vertical line like this. Here it is, Shabab, this one. Then you will find the distance from that line. I will call it x, ya Shabab, because it is, of course, on the x-axis. So it is some number between x, between a, and it could be here, it could be here, it could be at any place. We just choose it to be here, and we will call it arbitrary x. So you can, of course, write it here as x equals to x if you want to understand what is it. It is a variable. And here, this is the axis of rotation. What is x here? X here is what? X here is 0. So now, if you rotate it, you will have this will be the radius of the shell. If you rotate it like this will be the shell, the radius of the shell, and the distance from here to here will be the height. Now, clearly, the distance from here to here is x minus 0, so it is x. So here it is r here. R equals to x, and the height, which is h, will be y minus y equals to f minus y equals to 0. So it is f of x minus 0. It is f of x. Just you will substitute. And here we are. We need just to draw a line parallel to the axis of rotation, not perpendicular like what we did before. In the case of cross sections method, usually we draw it, of course, usually we would draw it perpendicular to the axis of rotation. Here we draw it, the Tribeca rectangle, we draw it parallel to. Of course, here, this is, as I told you, this is R, this is H, and this is the thickness variable. Let's put an algorithm to finding the volumes by using the Shells method. طبعا, regardless the position of the axis of rotation, if it is parallel to the x-axis or to the y-axis, what you need to do to use this, Shabab. You need first of all to sketch, and to sketch here you need to draw the region and sketch a line parallel to the axis of refulsion. It is very important. So we will do it parallel, not perpendicular like what we did in the cross sections method. And then you need to find the formula for the shell height and the shell radius. You need to find R and H. So what is R and what is H? Please, ya shabab, pay attention to this. This is very important. What is the shell height and what is the shell radius? The shell height is the line's length. You remember the line that you draw here? The length of this line is the shell height. And the distance from this line to the axis of refulsion is the radius. Just like here, if you remember, let me remind you, here it is, ya shabab. Look at this. The distance was from here to here, it was what? It was the radius of the shell. And the length of this line, it is the height of the shell. Just like that, you need to do two lengths here to find R and H. Then you need to find, of course, the limits of the integration and the thickness variable. Is it delta X or delta Y? And of course, after that, you need just to multiply 2 by the shell radius, the shell height, dx. This is just, if you remember, this is just the integral of A to B, 2 by RH. dx or dy, it depends, is your axis of rotation is vertical or horizontal? Is it the thickness variable is X or Y? Let's apply what we have learned now to solve the first example that we started with. Do you remember it? Now, let's apply now this method for this. The axis of rotation is the y-axis. So what we will do, I will, no need, by the way, to draw that, but it is okay. If you can imagine how it looks like your solid and how it will be, is it going to be a washer or a disc or a shell? Now, if you have a curve like this is the curve that we have. Let's say this is, here it is. This is 0, this is 2, okay? Now what we will do, Shabab, this is the axis of rotation. Now, what is the first thing to do if you want to use the shell method? You will draw a line, parallel to the axis of rotation, not perpendicular, parallel, okay? Then you will call it, because it is vertical, Shabab, you can think about it like a rectangle if you want. You can draw it as a rectangle, no problem. Now, since it is some number between 0 and 2 and it is on the x-axis, so we will call it x. It is, of course, vertical line. You know that for any vertical line, the equation will be x equals something. So here we have x equals x, but it is not practical to write it x equals x. I think it is enough to realize that this is x here. Now, the next step is to find, now the distance from here to here, Shabab, from here to here, will give me what? Will give me R. This will be the shell radius. And the distance from here to here will give me the height of the shell. So R, in this case, what is R, Shabab? What is the distance from here to here? Just look at this. Ask yourself, what is the length of this line? What is x here? X here is x, variable. And what is x here? X here on the y-axis, 0. So the length here will be x minus 0. It is x. So the radius here is x. Now, what is the length of this line, the vertical line? You have a vertical line now. What is y here? What is y here? Y here is
f of x.
2x squared minus x cubed, and here minus x cubed, not 2. And here y is what? Y is 0. So now h, the shell height will be just 2x minus x cubed. This is so clear. Now, what will be the volume? The volume will be the integral, because this line, Shabab, the line that we draw is a vertical, is perpendicular on the x-axis, so we will integrate with respect to x. From where to where? X is start at 0 and stop at 2. So it is from 0 to 2. Now it is 2 by RH. What is R? R is X. What is H? H is 2x squared minus x cubed. That's it. This is the integral that we are going to calculate. You know how to find this integral. This is not our target in chapter 6. This is chapter 5 issue. Just multiply, expand, and then apply the fundamental theorem of calculus, of course, the basic table of indefinite integrals. Add 1 and divide by the new power. Here it is. Okay. Let's take another example to make it more clear. It is a solved exercise. We have here our region bounded by y equals square root of x. Y equals square root of x. And the x-axis. This is the x-axis, y equals 0. And the line x equals 4. This is the line x equals 4. This is the x-axis. Now, this is my region. I have the region. This region, it is what? It is revolved about the y-axis. So this is the axis of rotation. Then find the volume of a solid. Now, what we will do, Shabab, who can tell me, please? What we will do, Shabab, to apply, of course, the volume of, to find the volume by the shells method.
H equal root x.
No, what is the first thing to do? We sketch the region. There is something remaining to sketch, Shabab. What is it?
Draw
A vertical line.
Draw a line that is parallel to the axis of rotation. This is the axis of rotation. It is the y-axis, so it is vertical line. So we will draw a vertical line at any place, Taman. You can draw it here, 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 whatever. So let's say that we will draw it here, and here we have x. So here we call it x here. Okay. So now what we will do, we will find the distance from here to here, from this line to the line of rotation, and this will be r. And we will find the length of this line, and it will be h. So the volume will be equals to the integral of 2 by RH d what? Because this line is perpendicular on the x-axis, so the thickness variable, the Tribeca rectangle will be like this, so it will be delta x. So it is with respect to x. From where to where? X is start here, and it stop at 4. So it is from 0 to 4. So the integral will be the integral from 0 to 4. 2 by, what is r, ya Shabab? What is the distance from here to here? What is x here? What is x here? X here is a variable, it is x. And here it is 0. So it is x minus 0, it is x. Now, what is h? H is this line length, the length of this line. This is the line. What is y here? What is y here? Y here is square root of x, and it is always the upper curve, and this is y equals 0, and it is always the lower curve. So it is square root of x minus 0, it is square root of x dx. And this is not difficult integral, Shabab, to be evaluated. Very easy. Okay? By the way, can we apply here the methods that we learned in section 6.2? Of course we can. You can here use what, ya Shabab? You can use the cross sections method. In fact, your cross section will be what? If you want to use 6.2, what it will be? What will be the cross section, ya Shabab? If you want to use 6.2, it will be a washer, yes. And you need to find the inner radius, outer radius, but I think this is much easier. I know, ya Shabab, that most of the students, most of you will use this method. It is, of course, it works with most of, not all, of course, but most of the regions. You can, of course, use this method. If you have an easy integral at the end, because in many situations you will have a complicated exercise that you need the techniques of chapter 7 to use. Let's take another one. The region, the same example, by the way, the same region, but this time it is rotated about the x-axis. Here it was rotated about the y-axis. Now the axis of rotation here is the x-axis. What will be the difference? Let's see together, Shabab. Now what we will have, this is the region. This is 4, this is 0. You remember the region from the previous example. And this is now, this time, this is the axis of rotation, the x-axis. So what we will do, Shabab? What we will do to use the shells method? Speak up, please.
To draw a line parallel to the axis of rotation.
We will draw a line parallel within the region. We will draw it within the region. What I mean by within the region, from the right to the left. It could be at any place, ya Shabab. So we choose an arbitrary place here, and this arbitrary place, it will be here y. Let's say, because here x will be the same, y will be a fixed here. So it is a number. Y here is a variable between 0 and what? And we need to find this. What is this, ya Shabab? What is the intersection points of these two graphs? Y equals square root of x, and y equals 0, and y equals 0, and y equals and x equals 4. So when x equals 4, what is y? It is 2. So this is 2. This intersection point, it is 4 and 2, and this intersection point is 0 and 0. Now by using the shells method, what we will do, ya Shabab? We will find the distance from here to here. This will be the shell radius. The distance between the line that we draw and the axis of rotation will be the radius, r. So now it is indeed, what is it? What is the distance here? What is y here? It is a line like this now. What is y here? What is y here? Y here is y. It is a variable, and y here is 0. So it will be what? R in this case will be y. And of course, the thickness variable will be delta y, because here it is perpendicular. It is perpendicular to the y-axis. So we will integrate with respect to y, by the way, when we find the volume. The volume will be 2 by RH dy, not dx this time, because this line is perpendicular on the y-axis. What is remaining is to find, now we have r. R is what? R is y. What is h? H will be the length of this line. So the distance from here to here is h. So we have this line now. We need to find its length. You need to ask yourself, what is x here? What is x here? To find the length of any horizontal line. So what is x here, Shabab? X here is what? X here is 4. And what is x here? At this place, what is x?
X.
X, it is y squared. Just you have y equals square root of x. Solve it for x. You will square both sides. So you will have x equals to y squared. So x here is y squared, and x here is 4. So to find the length of this line, which is the h in this case, this is h, it will be 4 minus y squared. So here we have 4 minus y squared. Now integrate from where to where? Y value طبعا يا شباب, delta y. Y from where to where? This is the y axis. Y start from where? Look at the region. It starts from 0 up to where? What is the interval of integration? Up to 2. So this is your integral. The volume will be just the integral of 2 by y multiplied by 4 minus y squared from 0 to 2. And of course, it is not difficult for you to find this integral. What you will do, you will expand, then evaluate, and then you will have 8 pi. What do you think, Shabab? What it was easier to use here, the shells method or the cross sections method, discs and washers? Let me go back to the I think we have it here. I will do it again, no problem. Look at your region, Shabab. This is the region that will be revolved. In my opinion, the disc method here or the cross sections method will be easier. Of course, there is no huge difference But of course, it is clear, I think, for you, especially for those who understand 6.2. So if you want to use, ya shabab, the disk or the washer methods here, what you will do? This is the axis of rotation. What you will do to find the cross by using cross sections. طبعا you will draw a line perpendicular. You will draw a line perpendicular to the axis of rotation. This is 6.2 ya shabab. And you will ask yourself, what is the length of this line? So what is y here? What is y here? Y here is 0, y here is square root of x. And you will, of course, this line is perpendicular to the x-axis, so it will be the x, the integral with respect to x. X is start from 0 to 4. And what is the length of this? You know, it is just by r of x all squared. The cross section here is a disk because the axis of rotation is the boundary of the region. And what is r here? What is r capital here? R of x will be the upper curve minus the lower curve. It is square root of x. So this is just square root of x all squared. So it will be what? The integral from 0 to 4 by x dx. And this is equals to what? 2 by x squared over 2 from 0 to 4. What is it? It is 16 over 2. It is 8 by. And this is the same volume, shabab, that we found here when we used the washer, the shells method. Here it is. It is the same answer. But of course, here the disk was easier. It is not, of course, that huge difference, but of course, it will save some time for you. So it is important, ya shabab, to decide which method we are going to use. We will focus on that more, inshallah, at the end of the class. Find the volume of the solid obtained by rotating about the y-axis, this region. And this region, we have sketched this region before. If you remember, it is the region between the line y equals x and the square root of x, this region. Okay, and the intersection points are 0 and what? 0 and 1. We did that in 6.2, if you remember. This is the region. Here region. We will rotate it about the y-axis. So we will apply the shells method this time. To find the shells method, again, what you will do, you will draw a line or a rectangle, if you want, parallel to the axis of rotation. Here it is. Then you will find the distance from this line to the axis of rotation, from here to here. It is x in the way, by the way, this is r. And then you will find the shell height. This is h. So h in this case will be the distance from the upper curve, which is y equals x, to the lower curve, which is y equals x minus x squared. X squared. In this case, you will have h. What is h? H will be x minus x squared. So you have r, you have h, then integrate. You will integrate with respect to x because the line that you draw, or the thickness variable here, is delta x. It is perpendicular to the x-axis. Here we are. But again, shabab, if you remember, we used the washer method in section. We used for this specific example. We used also the washer. You can use the washer method if you want to use the cross sections method. Here we have another example: square root of x from 0 to 1 about the x-axis. This is your region. This is, by the way, the same example that we had in 6.2, example number 2. What is the region? Here it is. This is y equals square root of x from 0 to 1. Now, if you want to use the shells method, what you will do, again, what is the axis of rotation? It is the x-axis. You will draw a line or a Tribeca rectangle parallel to the axis of rotation. Then the distance from this line, to the axis of rotation is the shell radius, is r. And the length of this line, the length of the line that you draw, it is h. Make sure that you have only one curve to the right, one curve to the left. And of course, ya shabab, what will be r in this case? What is the distance from here to here? So we call it y, so it will be y minus 0. What is y here? Y is y, and y here is 0, so it is y minus 0. And what is the length? The length will be just the distance from here to here. What is x here? What is x here? What is x right? What is x left? So h will be here. X here is 1 minus what is x here? X here is y squared. Now you will integrate with respect to what, ya shabab, here? With respect to what? With respect to y. Because your line, your Tribeca rectangle is perpendicular on the y-axis. طبعا this problem, the desk method, if you remember, it was simpler. Just go to example number 2 in 6.2. Now, I think this is the last example. Find the volume of the solid obtained by rotating the region bounded by this curve and this curve about this line. Now, what is this, ya shabab? The first curve is what? Is a parabola. You need to sketch this parabola. You need to write it in the standard form to have more accurate. So it is x, but by the way, I can give you techniques. If you remember the techniques that you learned in MATH101, you can write it as x. Let me continue this and show you both. So this will be equals to negative x squared plus x equals to negative a common factor x squared minus x. You will add then the square of the half. You will add fourth and subtract fourth. This will be negative x minus a half plus 1 over 4. So this will give you the vertex now. The vertex is a half and 1 over 4. 1 over 4 like this here. So this is the vertex. So it will opens down because this is negative. But of course, ya shabab, you can deal with it in a different way. You have y equals to x minus x squared. So it is x as a common factor, 1 minus x. You remember, this is of course because the coefficient of x squared, the leading coefficient is negative, it will opens down. Now you have the x-intercepts. What are the x-intercepts? X equals 0 and x equals 1. So here it is. This is 0. This is 1. And it opens down, of course. So it should be like this. So you can use this method easier than this method. Just we need to sketch here. So this is 1. This is 0. And our graph will be like this. I just show you how to sketch the region that you have. So the region is between it and between y equals 0. Y equals 0 is the x-axis. This is y equals 0. Now what we will do, shabab, this is the axis of rotation. X equals 2 is the axis of rotation. Now we will apply, of course, here of course, it is practical to use, of course, you cannot here use the other methods. They are not practical at all. So it is better here, of course, to use the shells method. So what you will do, you will draw a line parallel to the axis of rotation. The axis of rotation is vertical, so draw a vertical line. Since this vertical line is perpendicular on the x-axis, we will integrate with respect to x. Now the question is, what is the distance from here to here? This will be the radius, and the distance from here to here will be the height. So r in our case, shabab, who can tell me what is r? What is the radius of the shell? By the way, if you rotate it, it looks like this. So who can tell me what is the radius of the shell? You know that the radius of the shell is just the distance from the line that we draw until the axis of rotation. So what is it?
2 minus
2
It
minus
is a horizontal line. It is a horizontal line. You need to ask yourself, what is x here? X here is 2. And what is x here? X here is 2. What is x here? X here is a variable. It is x. So this will be the length of this line will be 2 minus x. You are right. Thank you. Now, what will be the length of this line, which is h? You need to ask yourself, what is y here? What is y here? So for h, what is y, ya shabab, here? Y here is x minus x squared. What is y here? Y here is 0. So it will be x minus x squared minus 0. So it is x minus x squared. In that case, of course, the volume just will be the integral 2 by, this is r, this is h, dx, because it is with respect to x. Now, from where to where, shabab? Clearly, x start at 0 and stop at at 1. So the interval of integration is from 0 to 1. Because just we find the intersection points between this and this, you will have the intersection, the x-intercepts are 0 and 1. I wish that this method, Shabab, is clear for you, because this is the last example and we need to summarize. To summarize, let me summarize here. So this is the cylindrical shells. If your rotation axis or the line of rotation is parallel to the x-axis, it is horizontal, then you will integrate with respect to y, because as I said, we will draw a line parallel to. So this will be perpendicular to the y-axis. So we will integrate with respect to y. We will integrate with respect to x if this line is parallel to the y-axis. The question is, what is this a? We will integrate what? This a is just 2 pi RH. What is r? R is the shell's radius and h is the shell's height. This is the cylindrical shells method. For the cross sections method, which is of course 6.2, if the axis of rotation is parallel to the x-axis, you will integrate with respect to x. If it is parallel to the y-axis, you will integrate with respect to y. The opposite. Okay? And what is a in this case, ya Shabab? It depends. If your cross section is a disk, then this a will be pi multiplied by the radius of the disk. If it is a washer, then it will be the outer squared minus the inner squared. The question now that you should ask yourself is how to decide disk or washer, which method I should use, cross sections or shells. Okay, so in fact, when you compute, you need to consider the following. Ask yourself these questions. Is the region is more easily to be described by top and bottom boundaries, or by right and left boundaries? By functions, by y as a function of x or x as a function of y? Are the limits of integrations are easier to be found for x better than for y, or the opposite? Does the region require 2 separate integrals or more, or only one integral? It is better to have, ya Shabab, 1 integral instead of 2. Also ask yourself this question, because when you use the shells method, you will have some situations that the integral is difficult. You cannot integrate. So after that, if you decide that one variable is easier to work with, you need, of course, to decide the thickness variable. You will integrate with respect to which variable. And you can imagine, ya Shabab, the revolving. Imagine your solid, how it will be. And imagine in that case, are you having a disk or a washer or a shell or whatever? Let's apply this together with this example. I think we still have like 2 minutes to work together. This is, ya Shabab, a very interesting exercise, but I advise you please to solve this. This is a very interesting exercise that will clarify for you how to do the same region, how to find the volume of the same solid, of the same region, of course, but rotate it about different lines, and you will have different solids in this case. Please, ya Shabab, tell me how to solve this. Using the method of cylindrical shells, the volume of the solid obtained by rotating this region bounded by this curve, and this curve, this is the x-axis, and it is rotated about the line x equals -1. Who can tell me what is the right answer? Unfortunately, we don't have time, but no problem. I will take 1 minute more, ya Shabab, from your time. So what we will do, we will draw the x-axis and the y-axis. What is the first curve, ya Shabab? It is what? It is a parabola that is opens down, and the vertex, it is 1 and 0. This is y equals to 1 minus x squared. This is 1. This is the x-axis. Y equals to 0. What are the x-intercepts, ya Shabab? Y equals to 0, x squared equals to 1, x equals positive or -1. So this is -1, this is 1. Now this is the region that we have. This is our region that we will rotate. Of course, ya Shabab, if you want to leave, you can leave, but we will stay just for a few minutes. I think 1 minute is enough. Now what we will do to apply, ya Shabab, what is the axis of rotation? The axis of rotation is this, x equals -1. I need a pen, not a highlighter. So this is the axis of rotation. x equals -1. Okay, x equals -1 is the axis of rotation. Now what we need to find to use the Shells method. So we will draw a line parallel. This is the line that will be parallel to the axis of rotation. Now the length of this line will be h, and the distance from here to here will be r. So in this case, ya shabab, what is the radius? The radius will be, what is this line? Because it is a vertical line.
+1.
It will be x minus, ask yourself this line. What is x here? X here is x variable. X here is what? Is -1. So it will be x minus -1, it will be +1. And what will be h? H will be the length of this line. So this line is a horizontal, a vertical line. So here y is what? Y here is what? Y here is 1 minus x squared. Y here is 0. So it will be 1 minus x squared. Now the volume will be the integral with respect to x, because we draw the line perpendicular to the x-axis. From where to where? X start from where? From -1 up to 1. 2 by RH. What is R? R is x plus 1. What is H? H is 1 minus x squared. Here it is. Look at your integrals, ya shabab. Clearly that the answer is what? Is A. These answers, when he double it like this, is not correct. Of course, this is not even. Okay, we are done with 6.3. We will practice, ya shabab, inshallah, next class by solving